Hi, good morning, scholars. And this week we're going to be getting introduced to the concept of stoichiometry. Up to now, you've been balancing equations and you've been being able to tell the type of equation or chemical reaction that you have. And as we realize, based on the law of conservation of mass, whatever you have on the left side of your equation, on the reactant side, should, by the law of conservation of mass, produce the same amount on the product side as far as the mass of total substances. Okay, that includes the molecules that make up compounds, and it also includes individual atoms. Okay, so we move forward to understanding that now that we know the relative proportions based on the coefficients, which is the number in front of the molecule, now we get to predict how much of a substance we'll have based on what we start with and what we end with. Okay, so it's all coming together now, but first we have to define a few things and make sure you have your document open, that you have your chemistry guided notes tracker. All right, hopefully you have engaged yourself in the idea of counting something that seems like it's impossible to count just by estimating the amount of dimensions it has and then using that. That was in the Girl Scout cookie example. Now we're going to apply that, but to a more specific example of chemical equations. Okay, so first, what is stoichiometry? Stoichiometry, right? Sounds like a long, fancy word, but the reality is all it is that stoichiometry is the amount of something. The amount of something, and that something is atoms, involved in the reaction. How much of each part of the reaction is involved? It's just that simple. Now, how we measure that? We measure that with those little coefficients that appear in front of the chemical that we call moles. A mole is simply the relative measurement of that thing that's reacting and that thing that's produced. That thing, again, being atoms and molecules. Okay, so far so good. Now, just like if I say that we have a dozen of something, it is a relative number that's associated with that dozen, and there's a special number that relates to that. This number, the name of it at this point is not as important. It's called Avogadro's number, but what I really want you to focus on is that 1 mole of something, okay, as you can see in a situation here with sodium, Na, if you don't see anything in front of it, we presume that there is 1 mole of sodium. 1 mole of sodium has a certain mass associated with it. We know this because in the periodic table, the molar mass of sodium has a specific value. Okay? So if I say 1 mole of sodium, it means the amount of sodium that can produce this specific number. 1 mole is equal to, get ready for this because it's kind of big, 6.022 times 10 to the 23rd, which is almost like saying 60 billion trillion. Hard to imagine that something can be that massive an amount. But remember, we're talking about atoms, which are very minuscule in their mass, right? So when we see things like coins or, marbles, we know that those have specific masses that we can actually count, or Girl Scout cookies, right? But in our case, when we're talking about atoms, they're so small that we measure 1 mole of something to equal 60 billion trillion. Unimaginable. So eventually we use this value when we need to find relative amounts. But for now, all we need to know is that a mole is represented by the coefficient in front of the atom or the compound. In this case, there's a 2Cl, so then we have 2 moles of chlorine, right? So if I were to set this up as a ratio of these 2 atoms, I would say that for every 1 mole of sodium, I have 2 moles of chlorine. That is how it breaks down. So let's recap again. Stoichiometry is the measurement of some things that are involved in the reaction, meaning the reactants and the products. A mole is basically the measurement of how we relate those things. Like if I say a dozen of eggs, well, I say 1 mole of that atom or that chemical, right? Now, the mole is relative. That means that it's proportional to the other parts of that equation, right? Thus, that 1 mole equals 6.022 times 10 to the 23rd, okay? And that is also going to be a measurement associated with that, which is grams per mole. We'll get to that soon. But for now, that's what you need to know. Stop and jot and make sure that you have those definitions down. Hit pause and make sure you fill this information in your study guide.